Hey everybody, I was like, why can't I see myself? I was like, oh, I'm over here. I was getting everything set up. It is Friday morning. The start of stream's gonna be me looking like, where am I? And I was like, oh yeah, I paused the stream. Let's see who's here. Caroline is here. Mubarak's here. Ali's here. Lucy's here. How's everyone doing? Somehow I cut my hand. I don't even know how. I don't go outside. I don't know how I do these things. I don't know. It was putting up groceries. I don't know. Hey Kayla, good to see you here. Pause the stream. I was like, where am I? See me start, and I'm like, oh. I'm on my second cup of coffee. Macy, good to see you here. Clayton, good to see you here. How's everyone doing this morning? Sorry for all the confusing emails. We got the code in the background. Let's show the code. No, we got effects going. What? There we go. I don't even remember hitting that. Woo! How's everyone feeling with end of the semester? Did everyone have a good study day? How'd study day go? Let's show the code. Oh, that's why, because I have the Marvel. There we go. Perfect timing with the music right there. How was everyone's study day? I had a pretty good study day. Got everything going. Had a good review. Just lots going on with the end of the semester. Study day was full of studying. Been up all night. Do people have finals today? Who's had finals today? We got Quick Gazelle. There's 12 questions in this Kahoot. And if we only have like 3 people playing right now, 3 people win prizes. My gosh, could you imagine? Oh, 4 people now. 1 person doesn't win a prize. Good to see you, Macy. Everyone's saying what up to each other. 4 people, 1 person will not win a prize. Now 3 people. See, I shouldn't phrase it that way. Half the people here will win prizes. Make sure to email me. We got 8 people. How many people do we have watching right now? That's a good metric of how many people. Max 14. We'll see if we get a few more people joining in here. Make sure to ask questions during the Kahoot. It's one of the big things with the Kahoot right here, asking questions. Let me put it this way. Oh, Arctic Dog. Got a bunch of people here in the Kahoot now. Questions in this Kahoot are on the final. Who's excited about that? Anyone excited that? Good to see you here, Great Turtle. Is anyone excited that the questions in this Kahoot will be on your final exam? Not like maybe. I'll be mostly taking notes. I need that, Reed says. William's excited. Ryan's excited. They like that right there. So make sure to be taking notes. Tell other people to watch the Kahoot. I mean, you just put them on your cheat sheet. I'm not saying anything, but I'm just, I'm saying, maybe I shouldn't have put so many on there, but maybe these are important questions that some of these questions may or will, because I have it set up that way, appear on your test. So really, really good. Like, if you're like, I didn't get anything out of the Kahoot. Well, then what'd you do? Did you not write down answers? Did you not review? So stay focused, stay reviewed. We'll get started here in 1 moment. Let's put on 1 minute. Not 1 moment, 1 minute. I'm not saying, but I'm just saying right there. Not saying, but that's how you get people's attention. You're like, these will be on the test. I think about when I perked up in class. Teacher's like, I'm like sleeping. It's like, this will be on the test. What? This will be on the test? What's going to be on the test? What was that? What's going to be on the test? Teacher's like, you missed it. I'm like, oh no. And then I'm like, but this class is recorded. I can watch it at any time. But no, really great. I should update everyone on the percentages. The afternoon class, we got an afternoon and evening class. The afternoon class, which I think is Lucy's class, got 98%. 98% of people completed it. And the evening class had 84%. And so they didn't get the last bonus. But both classes have the extra assignment drop, activity drop, and then the earlier class got the point. And so thank you everyone who completed it. I was looking at the percentages like, no, but Lucy was a huge, I know 98% is crazy. It's all right that the one person didn't do it, which I didn't want it to become like, who's the one person? But the good news is like a lot of people's grades won't come down to that. Yeah, and thank you, Lucy, for you probably got us another 10% on everything, and even putting it in the 201 chat. 201 percentages are also higher than they usually are. So don't worry, everybody. Work hard. Just give your best foot forward for the final. And so is everyone ready to practice? Let's see some awesome percentages. Who's ready for the review right here? I hate giving that downer news. It's just, I felt bad. Like, I saw it and I was like, no. It's not the end of the world, though. Don't worry. We got this. Because you know what we can do? We can do well in the final. We can do well in the take-home. A lot of people have A's going in right now, so let's do well in the take-home. Let's do well in the final. We got the extra activity drop. We got the extra assignment drop. Those are going to help bring grades up. So we got two great things. So is everyone ready for... I don't... What if someone did that? Oh my god, I see like half the students just switch over to the other section. They're like, hey, they're opening seat in this section. The university's like, what are you doing? They're like, yeah, I'm just switching sections here early in the semester. Let's do this. We're gonna start here at the end of the music in 3, 2, 1. Let's go. Here we go. Time to Kahoot. Don't worry, it says 474. Don't worry about that. I removed those questions. Let's do this. I was updating the Kahoot, so do not worry. Multicollinearity. What the heck is multicollinearity? What does multicollinearity show us? What does multicollinearity show us? Multicollinearity. Don't worry, there is no 474 in this. Multicollinearity. Multicollinearity is measured by variance inflation factor. Variance inflation factor is a bad thing. Hint for later questions. Variance inflation factor is a measure of the shared variation. Can't really appear because it's going to be the blue one right here. The shared variation in the x's. So the x's, and great job, everybody. Wow, amazing job. We got, there are 14 people playing, but we had 11 great correct responses. Amazing job. Let's throw some points out here. Mubot's awake. So the shared variation in the x's is multicollinearity. And what do you want your x's to bring? This is also on the test, not on the review, I don't think. But what do you want your x's to bring to the model? You don't want shared variation, which is multicollinearity, where the x's explain each other, measured by the r squared sub I. New information. William, great job right there. New info. You want them to explain y in new ways. And what does that mean? It means when you bring an x to the model, like you bring height, you wouldn't bring two variables like height measured in centimeters, height measured in inches, because what would, I will throw 200 points if anyone knows what the variance inflation factor would be if we had a variable of height measured in inches and height measured in centimeters. What would the variation inflation factor be for those variables now? So really quick kind of question on that, and it shows you know the concept. This is a much harder question, but what would the variance inflation factor be for if two x's were height measured in centimeters and height measured in inches, like two of the x's, which that's what we're talking about here. If you had both those in the model, what would the variance inflation factor be? What would the variance inflation factor be? And I'll show it here. 2 seconds. Let me hop to space, and I'll show you. Can anyone figure it out with the Marvel? Make sure. I'm going to see right here. Okay. The answer. Does anyone know before I tell you it? Oh, it'd be way over 10. That's a good answer right there, Abby. Abby, I'm going to throw you. It's going to be way over 10. I'll throw you 100 points for that. What percent of the variation So if you had two variables that completely explain each other, what would the r squared sub I be between the variables? If they completely explain each other, what would the r squared sub I be? If they completely explain each other, what will it approach? It's now theoretical. So two variables that completely overlap will have infinite variance inflation factor. And that's why when you look at the output for anyone who's done this, you sometimes get the NAs right here because it can't make the estimates. Yeah, so it's indeterminable, it's infinity. Exactly, Lucy got the other 100 points right there. It's indeterminable, it's infinity. That's why you get these singularities right here where they don't bring any new information, and we can't do that right there. So excellent work figuring it out. Teamwork, that's what we do right there. That's where I was watching the stream. I was like, wait, what's going on? Let's do this. Let's see who's in the lead. Got to be quick to get the points today. Elated Frog. Who's Elated Frog? Green Turtle. Awesome Pelican. Who's going to win the game? I don't know. Let's find out the next question. True or false? Variance inflation factor is a good thing. Oh, if you were listening closely, gave this one away. Teamwork makes the dream work. I like to drop some hints. My brain starts thinking about what question is next, but we were talking about variance inflation factor. Variance inflation factor is uncertainty, which variance is. Variance goes to creating intervals. If we're going to create intervals for estimates, we usually go out 2 standard errors. Variance is just standard error squared, so you can square root variance to get it. So it's a very, 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 very bad thing. So once again, variance, you should know this, that variance is standard error squared. Please write that. I'm trying to drop as many notes as I can give you right now, like concentrated information. Elated Frog, great job. But variance, like if the variance inflation factor is 25, that means that our uncertainty in the estimates is probably about how many times greater due to the multicollinearity. So let me repeat that. If, maybe you know it, yeah, we'll just repeat it. So if our variance inflation factor is 25, that means that our uncertainty in the coefficients has been increased by a factor of probably what? If our variance inflation factor is 25, our uncertainty in the estimates of the coefficients, yeah, knowing it is good. Not 100. Because remember, variance is standard error squared. So variance is standard error squared, and standard error is uncertainty. 5. You just square root it. So variance, if you square root it, you get standard error inflation. I wish we just called it that. I guess just by the way it's calculated. Yeah, I guess with the 1 over 1 minus r squared, it's variance inflation factor. But it would be 5 because you would square root 25 to get the standard error inflation. So we just take the square root. So I like to use numbers like 100 or 25 and ask like about how much, because then you just look at, I would take it if someone just, sometimes I put a margin of error on these things on Canvas to be like, well, even if someone doesn't have a calculator and it's like 24.8, then the variance and the standard error inflation would be something like 4.96. And you can just, I'll put a margin of error enough that I can be like, you don't really need a calculator. As long as you can figure this one out, square root of 25 is 5. So with this right here, variance inflation factor is not a good thing. It's going to make your what's wider for your estimates. It's going to make your what's wider for your estimates. So when we think about when we have an estimate of a coefficient, we have uncertainty, and that's going to make what kind of things for our estimates of coefficients, which is where we take the estimate and we go plus or minus 2 of these, the margin of errors. It's going to make our confidence intervals wider, which are related to the margin of errors. So the standard error is the uncertainty, and so it will make standard errors, which are kind of like standard deviations. And so the margin of error, which is built off of the standard errors, is going to get wider. And then our estimates might contain 0, and then the p-value would be what? This last little bit of knowledge I'm dropping on this one. If our estimates contain 0 as a possible estimate, then our p-value must be what? So if we're talking about, we're making estimates of coefficients, we have intervals that are very wide, very uncertain, contain 0 now. 0's over there. And so 0 is contained. So now the p-value is going to be, it's going to be insignificant. Does that make sense? Because we're saying this might have a 0 coefficient. I'm doing as many review topics as I can, above 0.05 exactly. Because if the coefficient might be 0, then it's not statistically significant. It might, because I'm doing too many topics. I'm on a caffeine high right now. What model would have all x's equal to 0, where no x's would have coefficients? What model would have no x's in it, would have all x's with coefficients of 0? The naive. So we're saying, this model is no better than the naive if we're saying the coefficients of these x's might be 0. So there's a good, we're just hitting as many review questions as we can as we think about these things. So we don't want the coefficients in our model to possibly be 0. We want to say they have some non-zero coefficient to them. Great work. Another 100 points. Everyone, great practice. I know I'm throwing concentrated knowledge. Don't worry. Practice, practice, practice. You're hearing questions that are on the test right now. If you know these, it's all right if you're part of the 4 that didn't get it. But if you're in the 11 who got this right away, you would have got to this test question and you would have got it right. Let's do another one right here and see how you're doing. But let's see the leaderboard first. Oh my gosh. Ooh. Awesome Pelican in the lead. Oh yeah. Inspired Quail, not far behind. Arctic Dog. Let's find out who wins with the next one. What's in this one? The partial F test is used to do what? This was in the latest assignment. The partial F test was used to do what? Once again, real test question. If you're freaking out because you didn't know every question that I said really quickly right there, don't worry. If you get this one, you are on track. If you don't get it, it's all right. Why are we using a partial F? If you did the most recent assignment, you should be like, oh yeah, I was doing this with my partial F. Why do we use a partial F? Let's talk about the other things here in a moment. But why do we use a partial F? We use a partial F to compare two models. So once again, if you got this, you would have got to this on the test without this Kahoot and been like, we use to compare two models. Good. So find the significance of the model. This is going to be where? This is actually also in Anova, but this is what function do you use to find the significance of the model generally? So take notes on this. Like if you're looking at the significance of a model, where would you see the significance of a model? What function are you going to run to look at the significance of a model? The significance of a model. Let me hop here to space and see. I'm going to bring up R in the background. Good. I have, yeah. Hop back here. The significance of a model is going to be what output is going to look at the significance of a model. Summary. Great job, William, right there. Yeah, don't worry if you get it. Don't worry. Don't worry. I think every time people are a little bit afraid they're going to get it wrong, but don't worry. Yep, summary. It's summary. Down here at the bottom is the significance of the model. So there's the significance of the model. Check variable significance. Variable significance is also in summary. So checking variable significance is over here in summary. So we don't use a partial F to check variable significance. That one is technically okay. Someone's like, well, okay, you could look at, a model with a variable removed. I'd use the drop one if I'm going to remove. So the drop one drops one variable out of the model. So if you want to drop individual variables, like gather up variables, it does a partial F for the utilization of dropping one out of the model total. So I'd prefer to say a drop one can be used to check the significance of individual variables in a model because it's not really larger and smaller models. Can you show the Anova output? Yeah. And so it is an Anova output. We won't focus too much on this on the test, so don't worry too much about this. The Anova output right here is also going to have the significance of the model. This is a logistic, so I think I have to, currently will test equals chi-square. So there's the p-value. Oh, it's looking at the, I've got a, let me change this right here. Where, I'm thinking which models I have stored in here right now. Here, let's make a real quick model. It's not wanting to give the p-value for the overall model because this one's logistic. Darn logistic models. More on those coming up. We're just going to do some classic right here. Good question, Lucy. And so let's remove the chi-squared test. And why is my brain not working? Is it? Oh, because it does the individual variables. So the Anova right here is running it with the individual variables. So when you have, we won't focus so much, don't worry. There's not a lot of questions on the test related to the Anova output. If you have a model like this, you will get the p-value right here. If you have a multiple model, it's a little bit more of a work. So it is running the Anova for you right here. This is the Anova for the full model. This is the Anova for the individual variable. If you have a multiple model, don't worry. This is a little bit beyond. I will not put a question like this on the test. This right here is the individual variables, but we did find this out. It was in one class we were talking about this, where the ordering actually matters right here, the order in which you put in the variables. So how does the partial F compare two models? So when you do the partial F, so doing the Anova, so Lucy makes a point right here, let's go ahead and throw in gender right here and call this M2. So now we're going to say going from M1 to M2, what is the difference in the sums of squares? So it's looking at the difference in the reduction. The degrees of freedom differences here are due to the differences in variables. I think we only included gender. So actually, Kayla makes a huge point that the Anova is actually comparing it to the naive model. So you're always actually within Anova comparing two models, and then the partial F is used to compare two models that are not the naive to not the naive to our model. So the Anova is always comparing two models, but the partial F compares two models where one is not the naive, and that's where we call it a partial F. We had a drawing earlier on where we talked about the naive being the lowest, and then your model being here, but when you do a partial F, you start partway through. Does that make sense? So this p-value right here is comparing going from this model to this model right here. So going from the smaller model to the complex model. But if you just run an Anova right here, with this Anova, and I wish we got the full p-value, you can get the full p-value by going to the summary. This p-value right here, which is done via the F statistic for the Anova, is going to give you the significance of the model. So great questions right there. Sorry. See, my brain shuts off every once in a while too. I know, but great answers in the chat. I'm interested in who's going to win. Lots of great questions. Let's see who's in the lead. Ooh, leaderboard's shaking up a little bit here. Let's find out. Awesome Pelican still in the lead. Lots of people close behind. It's going to be a close game. Number 4, R squared adjusted is what? Is R squared with a penalty? Is less than R squared? Can be negative. Can be used to equally compare models. Now there's a star on the is less than R squared because in the rare instance that you have an R squared of 1, they're the same. But all of these are true. Probably, and I do agree with everyone who put is R squared with a penalty. So what I most often say is just R squared with a penalty. It can be negative. That is true. It's used to compare models equally because it's going to penalize models so it can compare them equally. And in all instances but one, it's less than R squared because the way the penalty works, the penalty is based on how much unexplained variance you have. I don't go into details about that. That star over there is like the, I mean, if you had asked me like when I started teaching, is R squared adjusted less than R squared? I'd be like, yeah, always. And then I'd be like, oh no, I wouldn't know that one instance that when R squared is 1, R squared adjusted is also 1 because the penalty doesn't kick in unless there's unexplained variation. So don't worry. If I mention a little tiny thing like that, I don't like testing over little tiny details. And so, yes. But once again, I think the number one answer, I'm glad people answered that, is R squared with the penalty. It's the best way of thinking about it. See, I'm all out of it this morning. Who can't wait for summer? I can't wait. You know who can't wait for summer? Awesome Pelican. Oh, Awesome Rabbit versus Awesome Pelican. Everyone knows I'm rooting for Awesome Rabbit. Everyone knows I'm rooting for Awesome Rabbit. Let's find out. And I'm really, really excited because a lot of people are doing so well on this. Remember, these are questions that you haven't seen. So if you're getting these questions correct, these are just how we write test questions. Let's look at the next one, which could easily be so ready, William says. I know, right? Video games, relaxing, tacos. Standard errors are what? What are standard errors? You've heard me probably say this a lot in class. Standard errors are what? There are whats when we do things. Now be careful, there's answers here that kind of coincide with things. When you, yes, I totally agree. Everyone, wow, I'm just so excited how everyone's like, Brian's always called standard errors uncertainty. It's just our measure of uncertainty whenever we take a coefficient. Now, it does relate to widths of confidence intervals because if you go out 2 standard errors, if this question said right here can be used to create widths of confidence intervals, that is true. But I wouldn't say they are the widths of the confidence intervals unless you're doing a 68% confidence interval. Even then, it's not always exact. So the standard errors are a measure of uncertainty when we are trying to estimate a variable or a coefficient for the model. They can help with, or they can impact the level of significance because something is less likely to be significant when it has more uncertainty. Also, variance inflation factor impacts the standard error. But 11 people again, which I'm really excited, this is a good amount of people, are answering the question quickly and they know it. Awesome. Oh my gosh, that is a shakeup in a leaderboard. Awesome Rabbit. I mean, who's faster than a rabbit? Nobody, because they just destroyed that question, jumping way up on the leaderboard. Let's see who's going to win. Leverage is what? Oh, people should get this. I hope. There's a lot to read right here. So we've got right here the difference between a point and its prediction with that point removed. Sounds like something, but not leverage. How far an observation is from the mean of the x's. How far the observation is from the mean of the y's. The difference between a point and its prediction. Let's see. I don't want to give away the other answers too quickly yet. Good job. So let's go with one of the easier ones on here. How far, let's do this one. The difference between a point and its prediction. What is this right here? This is the easier one from 201. The difference between a point, like the y, and the y hat. The difference between a point, which is y, and its prediction, which is y hat. What would this be right here? The difference between a point and its prediction, like how much we miss by. Residual. Great job, Macy. Yep, that's the residual. So the residual is just the difference between the point and the prediction is the residual. How about the difference between a point and its prediction with that point removed? So now we're adding on a little bit extra to this where we have the difference between the point and the prediction, which we just called our residual, with that point removed. The deleted, and technically, don't worry, Lucy, 100%. Technically, this is just a deleted residual, and then we would studentize it. But the DSR, the deleted studentized residual, which is exactly what I'm going for right here. I think I ran out of words. Hint for a later question, maybe the next one. But a deleted residual. And then if we studentize it, which we should definitely do because that would put it to context. This top one right here is really, I guess that's the observation. How far an observation is from the mean of the Y's. That would be its sums of, or its error from the naive model. And we don't worry, that's not going to be a test question, but that would be its error from the naive model because the mean of the Y is the naive model. So the distance something is from the mean of the Y is its error from the naive model. We're not even summing or squaring it, but that would be, you know, we should know about the naive model, the mean of the Y. And there's no Y's. That's, I think, what threw me for a loop, and I wrote this. But there's no Y's. We're not doing, what's it called? There's multivariate Y regression, which, whew, I need to review that kind of stuff. Stuff you learn in graduate school that you forget. Anyways, how far an observation is from the mean of the x's? Yes, this is its leverage. Is leverage a good or bad thing? I mean, it's not. Do we like leverage? Do we like high leverage points? Do we like high leverage points? He's like, do we like them? Leverage can be an issue. Yes, exactly. If things have high leverage, they could have high influence because there's another characteristic. We're not a really big fan of high leverage because points can easily become influential. Good job right there, Sam. We don't like high leverage because points could become influential, and there might be another component. Let's see who might know that next component. Leaderboard's just going crazy right now. Dazzled Quail, you got this. Well, so more accurate in what way? Like the leverage is kind of like, think about it like a seesaw. And the further out you go, the more you can push the seesaw. So when we have more leverage, these variables, like imagine we had someone in our model who was 120 years old and we wanted to predict like someone's GPA at UT, like the oldest person alive attends UT. So that person, you know, a lot of people at UT, probably average age is about 21. Exactly. To Oliver, everyone remembers that example. So if someone like 120 years old attended UT, they would massively impact the model if they were a little bit off, because there's going to be a second characteristic that impacts leverage. So good to see you here, Cliff. Second question. Let's see. Did I ask it right away? Deleted residuals are what? Sorry, Tolliver. Rip Tolliver. Should tell him. Like, I talked about you today. He'd be like, why'd you talk about me? Or be like, call him up. Tell my brother, be like, can I put Tolliver on stream? Can he appear on the internet? I don't know what my brother would say. Be like, no. So deleted residuals are nice. Where is it? It's this, isn't it? There we go. Oh my gosh. Good job, everybody. Good listening. Once again, remember, these are actual test questions. And if you're getting them, great job. That's what we're here to do. We're here to practice. Once again, note that the difference a point is from its prediction is the residual with that point removed. Now, we would studentize it, which means turn it to a t-statistic. When is something, in terms of absolute value, what is a large t-statistic? I'm not saying like crazy huge t-statistic, but generally speaking, what is a large t-statistic? Generally speaking, what is a large t-statistic? Bigger in absolute value than what? Generally speaking. And we can cheat because R shows us what is, I've already got one over here because we're talking about that in officer. 2, yep. Outside of 2 or -2, that's a generally large t-statistic. So here's another influence plot. You can see right down here, we have things with high leverage. This means these points are very far away from the mean of the x's. This is not the mean of the x's. This is where high leverage begins. The mean of the x's has 0 leverage. This is an extremely high leverage point, but does not have... yeah, it's basically 1.96 is the z-score for a 95% comfortable, or 1.95996, I think. Sadly, I don't know. I have a big thing about memorizing numbers, so I like to... it's PT then, isn't it? Wait, what? Oh, P norm. There it is. Got to go Q norm. There it is. 1.95996. I don't know. I like that. So because 1.96 is classic, but then if you know the 996, you're just being Brian Stevens, which is don't do that. Don't be Brian Stevens. But it's basically 2. It's basically 2. So Lucy, and I really want to point this out, the big thing with especially the way we do statistics nowadays, it's really great because we let the computer do a lot of the heavy lifting. And so that's why I like to say basically 2, because one, if we're using a T, the T will always be a little wider than the Z. So if you were to go back here and you said, well, let's do the same sort of calculation. So we want to go to QT, but now we go to 0.025 with 60 degrees of freedom. Well, this is with 60 degrees of freedom, the T is actually very close to 2. So when we say it's basically 2, if there's high degrees of freedom, it's probably closer to 1.96. If there's low degrees of freedom, like if we go to high degrees of freedom, it's very close to 1.96. But if there's low degrees of freedom, it'll be much further from 1.96. So if we say it's basically 2, especially as, larger degrees of freedom. But the thing is when we do this, we don't have to worry about doing all the work because the computer will do it for us. Does that make sense right here? So I could tell you the standard error for this by going and taking the difference of these two numbers and then dividing this by 4. So the standard error for weight, which is the one I think I took, the standard error for weight, and it should be what I just calculated, I calculated to 0.0037, and it's 0.00378. So if you look at my very quick calculation by using basically 2 for this model that we just randomly had stored, I was down to almost decimal place accurate to this. This is where my decimals go wrong. So it's basically 2. And I used just the interval right here, and I divided by 4 because we went out 2 standard errors on both sides, or probably about 1.98 or something like that. But yeah, so it's basically 2. Good talk right there. Let's see who's winning. We have Awesome Rabbit still in the lead. I don't know who's going to win. It's a very close game. Let's find out right here. What is the reference month of the year? This is when we have categorical X's. What is the reference month of the year? I'm too afraid that people are going to put a certain month down. Put in the chat our saying after you've answered the question. What is our saying for all this? Because the next 2 questions are also going to cover this. Just need to go skip right there. What do we do right here? What is our saying? We got more people playing. Oh, we tricked a few people with January. Reference first, logistic last. And how do letters reference first? Little bits. Reference first, logistic last. So why did people choose April right here? Because when we are doing reference levels, the first one, if you look at the alphabetical order, the one that is first alphabetical will be the reference. So we'll talk more about logistic here in a moment, but when we have logistic, we have 2 levels in logistic. So we just do binomial logistic regression, not multinomial logistic regression. You can do multinomial logistic regression. We just don't cover it in this class. So if you're like, what if we wanted to predict a 4-level variable? Well, there's ways to do that. I can't remember what package it is, but there is one in R that does it pretty easily. We don't teach it because we only have so much time. And so when we say reference first, we're talking about categorical X's. All of these other months would be a what variable? All of these other months would be a what kind of variable in the model? All of these other months, April is going to be the reference level because it comes first alphabetical. And then all of these other months would have what's for them in the model? Indicators. They would all have indicators indicating that it is this month. And then what value would all the indicators be to show that it's April? There'd be 11 indicators. There's a question like that on the test I was just looking at. So because there's 12 months a year, there'd be 11 indicators. And if every indicator was 0, then it would be April. So know things like that, like with freshman, sophomore, junior, senior, how many indicators would there be if we had freshman, sophomore, junior, senior in our model? How many indicators would there be with freshman, sophomore, junior, senior? So how many indicators? 3. You just drop it by 1. And then what would be the reference level? So we'd have 3 indicators, and the reference level would be, I think I know which one I'm doing in my head. You are correct, freshman. I like double checked before I'm like, yes. I'm like, ABCD. If you listen, go back and listen to this stream. I'm like, ABCD. Yeah, I'm like, yes, F. So there we go. Got me up, Allie, right there. Great job. You understand how indicators and reference levels work. Oh, awesome, Rabbit. This is close. $50 Amazon gift card, $20, $10 Amazon gift card. Please email me with your email address and say, Brian, please send it here to this email address. Only a few more questions. Let's see who's going to win. If we are predicting whether or not someone buys a product, which of the following is true? Oh, I reviewed this. Now I'm worried. Ah, we got this. We are predicting, that's a hint right there, whether or not somebody buys a product. So I see some stuff about reference levels. Ooh, reference levels is all about those X's. And we're predicting something, which means this is a Y, which means we have a level of interest, which means we're using logistic with the level of interest. And logistic, the level of interest is last. Those are the hints. That's what should be going through your head when you see this in logistic. The level of interest is last. And that means yes is the level of interest. So in logistic, the level of interest is last. And so you have no and you have yes. So make sure to just list out LMNOP, QRSTV, WX, Y, and then Z. And so because of Y in logistic, the level of interest is last, we are predicting the probability of yes. It's a little bit arbitrary, and you can just see this when you make your model that we are predicting that level. As always, just, I think just making models, because all you have to do is change the variable here to like gender. And now we can't, if we want to visualize this, we can't have as many X's in it. Oh, haha, people should be saying something, and you might see this on your test. We are changing it to logistic. Now it should work. Good. So now when you visualize this, you get here probability of male. So as GPA increases, probability of male decreases. That is not the direct interpretation. We have 2 individuals who differ in their GPA by 1 point. The person who has a higher GPA is less likely to be male. That does not mean if you have a high GPA, you're not male, and it does not mean if you have a low GPA, you are male. It just means we have a person who has a 2.0 and a person who has a 4.0. The person with a 4.0 is what? We just did some interpretations. We have a 2.0 and a 4.0 person. The person with a 2.0 versus the person with a 4.0. Oh my gosh. Oh my gosh. I got a new phone. The ringer is very loud. I hate it when people call you and they don't leave messages. You can say more likely to be female, less likely to be male. That works right there. I left a message yesterday for Mark Summers of Double Dare fame, and I was like, I hope that's him. But it's a local number ish, Kingsport local. Person with a 4.0 is less likely to be male. Very true. 2 people who differ in their GPA by 1 point. The person with with a higher GPA is less likely to be male. Brian, what do you do with your life? I don't even know. I just get bored and I think of interesting things to do. I'm like, you know what? What if we had Mark Summers like appear at the start of a Kahoot, and Mark Summers was like, hey, Stats 1 students, asked him if he wanted to do it for Sunday. You're like, welcome to Kahoot. Oh man, that would just, whoa, what is going on with that leaderboard? I was just expecting to say, hey, look at the leaderboard. It's all the same. But dazzled quail, inspired quail. It's a quail battle right here. Awesome rabbit. Quail's pretty good, like food-wise. But we have this battle right here. Awesome rabbit still hopping into the lead right here. Let's find out who's going to win with that next question. Let's do this. When predicting a categorical Y, which method must we use? This is a review question now that you should know. We were just talking about this. I don't want to give away anything too much. Well, let's talk about these. Indicators are going to be for categorical X's, which this is not. Interactions, well, those are just something we do with the X's, which this is not. I don't know what's going on with me. And then we're down to these 2 right here, linear or logistic. Linear is what we started with, which is quantitative. We're talking logistic. So logistic is when we predict the probability. It's what you were seeing just a second ago right here where we're doing logistic regression. You should know quite well the form right here. And this is, I just, if I can give you a big hint, like, here, let's get serious. We're going to put on some serious, we're going to put on the sad music. When people are taking the final, sometimes I'm looking at the grades and I'm like, did we even cover logistic? Do people remember logistic? Like, they forget about it. It makes me sad. Because it's a whole world. It's a whole new world. Because it's dealing with a categorical X, so it's a different thing. And you have to, let's go to the main screen, let's see it. You have to know this. You have to look at this and say, that's predicting the probability of a Y. Sound of silence. We'll get DMCA'd for that. So you have to see what we're doing right here. And these are some clues right here. I love logistic. Al, you're right there. 100 points. I have the wrong copy paste. So logistic is all about that categorical Y. Two-level categorical Y for what we're doing, not multinomial yet. And when you see this, we're predicting a level of interest, which will be the last one. So you have female and male for this model. And so male is last. So that's the level we're predicting. And it's binomial because it's two-level. That's what binomial means. And yeah, make sure you know your interpretations. We covered that in class. Email me if you can't find the link for it. We covered some interpretations. We made a really good cheat sheet. I uploaded it for both classes. So please don't forget about logistic. Logistic loves you too. Don't forget about logistic. Okay, let's head back right here. Do not forget about logistic. One of the biggest things I see on the final is just people are like, did we even cover logistic? Entirely binomial Taylor. Over for that. Nice, Lucy. Lucy has reached 50 hours. Shout out to Lucy right there. Great job. Awesome work. Let's find out the next question. Ooh, it's a quail battle right here. Bunny's still got a shot. It's any, you just get one question wrong. This could drastically flip. Dazzled quails. They're like, did anyone get 12 out of 12? Let's find out. Well, we're not there yet. Okay, here we go. AIC measures what? There's not a lot of AIC related questions on it. But AIC measures what? Oh, people are like, wait a minute, we just covered this. Wait, Brian was talking about this last class or so. Akaike's Akaike. I practice saying it. Akaike's information criteria, which was developed in the 70s, which is very, very influential. Japanese. Hirotugo Akaike. How close our model is to the truth, which is so weird to say. The more negative it is, the better. A difference of 2 is very small. A difference of 10 is very large. So when we look at the AIC, Baka? I don't know. Is that Japanese? Lucy, you'll have to tell us if that's Japanese or not. I do not know that. So when you look at the AIC, oh my gosh. Why did Brian say, I mean, this is just like, if I'm going to tell you anything about these right here, Model 2, definitely go with Model 2. Like that is a, what does Baka mean? All I know Japanese is like domo arigato, which I know more Chinese than I know Japanese, like, we, nihama, hongheha. My Chinese is way horrible. I'm not even going to try. Or why ni? If anyone knows Chinese, you can tell me, Brian, I understood that, or Brian, just please stop. Brian, no. But at one point, I really wanted to learn Chinese. I had a few Chinese friends who would help me, and they would tell me, oh, is that what that means in Japanese right there? Oh, no. I asked to know how to say why ni to say it to Chelsea. So if anyone knows Chinese, that means I love you. So, oh, that's so sad. I know way more Spanish than I do any other language because I used to work somewhere where a lot of people spoke Spanish, and they would help me out a lot. I would actually tell them solamente español. They'd be like, no. They would want to speak in English. I'd be like, no hablo inglés, solamente hablo español. And they'd be like, and they'd laugh at me. They'd be like, no. But I'd be like, come on, just let's only speak Spanish, please. Anyways, the adventures of Brian. So what's going on right here? What's going on with these two models? Hola, profesor. Hola, Lucy. ¿Cómo estás ese día? So what do we have with these two models right here? These two models, what's going on with the AIC right here with these two models? What's going on with the AIC? What's the deal with those AICs? You could test me, see like how long could I conduct in Spanish? It would not be very long. I wish I could teach a whole class of Spanish. What's the deal with these AICs? No one knows. I said it earlier. What's a big difference in AICs? ¿Estoy bien y tú? No tengo mucho... Oh my gosh, I don't know how to say sleep anymore. I don't know how to say last night. I know noche. But I'm trying to think of last night. No tengo mucho sleep. 10 is a big difference. And we see this right here. And I'm not using past tense either. Dormir. So yeah. Dormiste. Unless I sleep, past tense. Oh, my Spanish is gone. Oh no. AIS, exactly, Ali. Here I'm trying to focus for last minute. AIS, we always have a little bit of fun at the end. So there's a big difference right here. The difference is way more than 10. And dormir is to sleep. Yep, there we go. I'm forgetting all my verbs. So there's a humongous difference right here. If we look at some other measures of these models right here, if we look at the summary between these two models, we see that this one has an R-square adjusted of 36. We go over to model 2, and this one, oh, these are two different models on two different things. Well, that's not a good comparison. Model 2, what is model 1 predicting? Here, we'll make this model 3. Okay, we have to have two models that are very similar in terms of what they do. Cool. AIC model 3. So here's model 2, here's model 3. Okay, model 3 is way better. And we will see, so I know French, not Spanish. I don't know French at all. I know j'attends mon petit chou. I don't know, I wish if I could learn 50 languages, I would. It'd be so cool. It'd be so much fun. A lot of respect for people who know multiple languages. Especially people who English is not their first language, like Julio. He's always like, hey Brian, we'll see who's in the lead. Oh gosh, this is a crazy game. This is an absolutely crazy game. But really quick shout out to Julio right there, who's always like, Brian, my English, it's not that great. And I'm like, Julio, I would never guess that English is your second language. And he's like, oh, my wife, and I'm like, dude, I would never guess. Mubarak, yeah, great job, Mubarak, right there. I don't know any Arabic, so Mubarak, if you want to tell us any Arabic or teach us any mon petit chou, my little cabbage, yeah, I like that little part of French. So Mubarak, if you want to share any Arabic with us, feel free to. One of my former roommates, he was Arabic, and unfortunately, I didn't learn any from him, but he would share a lot of the food. I think I mentioned that in class last time. But I got to have a lot of really good. He was from Saudi Arabia. I got to have a lot of really good food. So awesome stuff right there. And so, last question. Oh gosh, what have I done? Linear regression does which of the following? Woo! I should marhab. If you want to, yes, marhaba, marhaba. Pronouncing it like marhaba. Hello. Like marhaba. Let's see who's going to win. Say, Brian, that was too quick. Well, were you ready? Oh my gosh. It's going to be a close game. I fear that when I say things that I... Oh, assalamu alaikum. If that's how you spell it, that is. And does that go with God, I believe? From the Ukraine. Awesome. Interesting stuff. Thank you, everyone, for sharing. And please tell me if I mispronounce things. I always want to pronounce things correctly. But with that, and thank you, everyone, for sharing. I don't know. I find it, and I bet. Oh, do you guys see who won? Does it show you? Oh, I'm so sorry, Kayla. I'm so sorry, Kayla. You ready? Who's in the lead? I don't even know. This was a crazy game. Quick Gazelle. A lady frog. Wow. They were quick. Oh, Kayla, no. I had an early meeting this morning and my brain broke. Oh no, the Bengals lost last night. Ian, did you win? When you come, oh my gosh, great job. Who all won? Let's throw some points out to everybody. I threw a curveball out right there at the end. How do people feel about the test right now? How do you feel when you get 11? I wish you would just keep playing. Let's go watch that podium again. We'll put on a little music. How do people feel about the test? How are people? Adorable Lizard, was that, what place were you? Back to podium. Feeling good? Quick Gazelle right there. Great job, Lucy. I froze on the first question. No! That's all right. That's all right. We have a lot. No one got a perfect score, which is all right. But we've got a lot of really good scores right here. A lot of really good, like, and this was a very close game. You think we had, what was it? The Quails were fighting each other. I feel good about the lockdown portion. How many questions are on the exam? There are 50 points. 9 of the points are interpretation, I believe. 9 of the points are interpretation. Who here is excited about interpretation? Anyone here is like, I can destroy that interpretation. I will win on the interpretation. Does third place? Yes. Third place is $10. Make sure to email me. Third place is $10. First place is $50. Second place is $20. Third place is $10. And thank you. I feel bad sometimes because like sometimes I think it's interesting with teaching online. It's like you would think it'd be easier, but I think it's easier to sometimes teach in person, because when you teach in person, you can see people and you guys really help a lot. Email me with your email address, Ian, say send the Amazon gift card to this email address. So email me with your email address. You can email me on your UTA and say send it to this one, but whichever one you say send it to, I will send it to. And then you can tell people, yeah, Brian sends it out, because I'm always worried people are like, Brian doesn't send those out. No, I really do. And no, I really appreciate online teaching, but there really is something, like, I hope people have really enjoyed this class online, but there is something to, let me put that in the chat for you, Ryan. You got it. I'm gonna find that video for you. There is something to being in person. There is something special about being in person too, where you can kind of see people and you can, say hey, because the hardest thing, and I really want to say thank you to all of you, the hardest thing about teaching online is when things get really quiet, at least for me. And, everyone in both classes has really made it so awesome by, being here, by talking and interacting and answering questions, helping each other out. We say vols help vols all the time. But, carry this forward. Like, I'm not trying to be inspirational or anything like that, even though sad music is behind me. But please carry this forward. Please, in your other classes, whether it be in person or online, find those people who are struggling. Find those people who are not grasping the material and be like, hey, can I, were you wondering about this topic in class? I saw you had a question. Maybe it wasn't fully answered. And I'm sure your teachers, such as myself, will really appreciate that. Because sometimes it's not always, what I've found by teaching for quite a while is that I understand the topics really well. Like, I've been doing this a long time. I don't think it's arrogant for me to say I understand the topics really well. Like, I'd hope I understand the topics really well. But sometimes students can communicate the topics better than me, because students are learning the topic and maybe they understand how to have that light bulb moment. I'm finding the link right here to the video. Oh, I should just go to the class. So I'm finding the link for the video. Well, thank you so much, Reed. I really appreciate that. And that's what we want right here, is we want people to have this platform, have this engagement between each other. That's the goal of this, is to have engagement, to have a platform where we can come together. My brain's still turning on. I'm like, gotta figure out how to find that link. I'll have it for you in 1 second right here. I think it was Ryan asked about that. Yeah, let me see. Reviewing for final. Here it is. Okay. Copy link at current time. Here we go. Review for final. There we go. There it is right there. That should be it right there. That should bring you to it. But yeah, no, it's not just, so if I were to give you more advice, it's not just the professor that makes the class, it's also the students. Oh, thank you so much. So yeah, Kayla, and we just had a meeting this morning about online classes, and shout outs to people like Mark Moon, Dr. Mark Moon, Dr. Laura Cole, Ken Baker, people like that who are really working hard to make their online classes as best as possible, because I believe in online education, but I also believe in in-person education too. There won't be. I'm probably gonna do. So yeah, Mark Moon is the great. Everyone, he's. You know what? I've grown closer to people. Thank you so much, Lucy. I've grown closer to people by what I do now because a lot of people have reached out to me and we've like collaborated and worked together on stuff. Yeah, Dr. Cole is. I wish I had heard more from her this morning. I probably talked too much, but she is just a genius, a great person, and like an excellent educator. And I'm astounded by like the fact that I get to teach with some people like that. How do you think the workload will be if I'm taking both 474 and 475? I always say 474 and 475 are going to be like 320. So whatever workload you feel in 320, I had a student who found 320 to be an easy course. He went into 474 and he's like, this is easy too. That's not how everyone feels about the courses. I think the level of workload stays about the same. If you find 320 to be extremely challenging, extremely difficult, 474 is probably going to be at that level. If you find 320 to be like a course where you have to put in the usual amount of work, probably about that level. And the way I'm designing my 475, which is time series, is meant to be of that same caliber, where we're learning new things. So I think it depends on how quickly you learn coding, but also you're building a tool set. The goal with these courses, 320, 474, 475, is that you build a tool set over time, and we just have to keep working on it. It's like practicing a C scale, where like every semester it's like, let's practice that C scale, and now let's learn like a D scale with 2 sharps. Let's learn F scale with the flat, with the weird. You gotta, because F scale is weird. I always thought that as a kid. Anyone playing on a piano knows the F scale. You got that B flat right there where you have to switch over. Yeah, it's so weird. F scale is interesting, but we're just practicing. That's what we're here to do, is practice every semester, and then you just get better and better, and the simple things we learn early on keep getting used. So, that's what I hope to do with these courses. Oh, is it? Wait, no. Oh my gosh, F scale has a. Lucy, am I wrong? No, F scale just has. Oh my gosh, what am I doing? F scale has a B flat, right? Circle of fists. Go down C to F. You're going. G should have F sharp on it, right? I was thinking. Sorry, you scared me there. I thought I was wrong, and I was like, I was really worried. Lucy. I was like, what have I done to my brain? F scale is 1 flat. Yeah, if you go down the circle of fists on it, circle of fists. I didn't even realize how. Why didn't my teacher teach me about the circle of fists? If you know anything about like music theory, like why didn't they just show me? My mathematical mind would have been like, whoa, you just go like do 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 do, and you just go up the circle of fists or down the circle of fists so you can do the sharps and the flats. Yeah, you'd go up to, like you're thinking like F sharp scale or something like that. F scale has 1 flat. Yeah. I love music. I'm thinking about buying a piano. I've been thinking about it for a while. I don't know. Like, I don't want to buy a cheap piano, and I keep looking at them, and I'm like, okay, this $300 piano looks good, but I'm like, oh, this $500 one looks better, but this $800 one looks great. Why don't I just go $2,000, get like a really great one? Yeah, circle of fist is so cool, especially if you're just whatchamacallit. I really like. It was funny when I went to college, and I was not a music major or anything. I had a lot of people who would show me how to like just make up music and stuff, and they were like, well, you have to know a good bit of music theory, and I didn't understand. I'd just been taught, and I was good at memorizing music, but understanding why things sound good, which circle of fist deals with, really helps. And I wish, I don't know, I'm decent at piano, but I wish I was better. Wish I knew more languages. Music is a language. Kind of is. Coding's a language. Keep working at these things. You don't get good. So we talk about this right here. We're talking about music. F sharp was my favorite scale when I played flute. I miss playing. Yeah, well, maybe for your kids, to break out the flute and be like, hey, we're gonna, I'm sure. And, I bet you're encouraging them to like enjoy music and stuff. I'm speaking to myself also. Like, I need to go get that piano. Math is a language. Exactly. Math is like the language of the universe. Math is like, it exists. I would say if there was not a mind to observe mathematics, mathematics would exist absent a mind. Like if a tree falls in the woods and no one's around to hear it, would anyone hear it? Yes. I mean, would it make a sound? Yes. The answer is yes. The air vibrations would exist. We would know it just because no one registers it. I believe B flat supremacy. Trumpets are the best. Oh, Ian's starting some wars here with the trumpets. I had people once say that math is the language of science. Yeah. I'd say math is the language of just like, oh, just Celeste. You haven't done Celeste in a while. My husband plays trumpet and would agree. There you go. I started growing up playing piano at age about 5 or 6. I then started playing clarinet at age 12 and found out that I hate it. Did a little bit of guitar, never got good at guitar. I think I would get frustrated because I could play things on piano, and I was like, well, I can just play guitar then. And I'm like, okay, C. I might be able to play. I want to grab a guitar right now and see if I can still remember how to play a C scale. And then I learned about power chords, and I was like, okay, well, I'll just learn to play power chords. You know, just make a power chord and just play all like, and then you're doing theory also because you just have to know like how much up to go up and down. I dabbled with oboe and bassoon; those were so fun to play. Oh, I'm so sorry, Lucy. It's just like your lips get chapped. Gotta just play Black Sabbath. And Angry Video Game Nerd, I think, plays some Black Sabbath. He also played piano. There you go. In piano being percussion, I got used to it. Your fingers do get a little bit tired when you play piano, but rhythm supremacy drummer. There you go. Well, piano's percussion too. So you just gotta. I really liked. Man, I want to play piano right now. I had a few songs I made, and one of them was called Trainwreck, and it was a duet. And so Trainwreck, the duet, it was played with A minor, F, C, G, which is just a basic structure. For anyone who knows, like A minor, F, C, G, you've got your major chords and your minor chords in the C scale. So you start out with the A minor, and you're meant to start out as simple as possible. Like this song right now, you start out as simple as possible, like A, F, C, G, and then you increase it each time. So every time your goal is, it's like a game. Every time you start the next cycle, you have to increase it. So you go like A, C, F, A, C, G, C, G, C, B, C, B. And then you switch to like a chord and you're like A, B. Or no, not B. But you keep increasing it. And the other person tries to match you, but maybe outdo you a little bit. So it was just that guy who showed me how to do a little bit of improvisation. He would show me these things. And then you're meant in that moment when you start the next one to come up with something more that's rhythmic but increases it. And so I don't know. That was the funnest thing we used to do. We would call it Trainwreck. I came up with the idea. I was like, okay, wait, you just got to outdo it each time. You get to the next cycle. You just got to be like, at the end, you're just going like full like chords, and maybe you're reaching over the person, hitting the high notes, and you're like playing low notes, and they're in the middle. And it was fun because we would play it at this piano that was like in like this public area where all these games were at Appalachian State. And I remember people would just be like laughing at us, and then we'd be like, I don't know, maybe you're like, you just find something new to do each time. I think that's why I like teaching online. I don't know if anyone's even watching right now, but to me, teaching online is sort of this thing right here. Yeah, it was so much fun. I miss it. It's just, I don't know. That guy, it was just crazy. I just would see him around and he'd be like, you want to play some piano? But he was really good. People would tell me I'm good, but when you meet someone who like, he could play things by ear, he was one of those people like, people had like a CD player or something. They'd be like, hey, can you play this song? And they'd be like, I got my portable CD player. Gosh, 2000s, right? Early 2000s. And they'd play him it, and he'd be like, yeah. And he'd like play it by ear. He'd be like, I think I've heard that. He could play by ear. Really good. Just always amazed by amazing musicians. I mean, I could memorize stuff. That's my talent when it comes to music. Well, with that, be checking out the review. We had some fun today. Relax. I'm close to 100 hours. Can we keep this going for just a few? Yeah, why not? Let's hit that 100. I'm going to see. I got a text. Very important text. Yes. Okay, I need to... Wait, let me plug in my phone. Plug it in phone. Ah! You're welcome, Lucy. Bye, Clayton. Let's see. What is everyone's favorite song ever? You got to put your favorite song in the chat. That's such a hard question, Brian. I'm saying that to myself right now. What is your favorite? You can only listen to one song for the rest of time. What song is it going to be? This song right here. 100 hours. That's awesome, Kayla. I'm honored that that's your goal. I reset the points after the semester, so next class you take with me, your points will be reset, but your hours will stay. Favorite song that if I can only listen to one song, what would it be? See, I can't play them on YouTube. There's some good songs. 46 and 2, Tool. By Tool? I have to check that out. It's so hard. Like, this is like the one song, if I can only listen to one song. See, I like Ben Folds a lot, but I'm like, will I pick a Ben Folds song? X Japan. Oh, that sounds interesting. Do I pick K-pop? Do I pick my favorite K-pop song? Like, I want something that just like... Oh, no, I know what I'm picking. Okay, I'm picking something crazy right here. Starman by... Oh, that's really good right here. I'm going left field. Brian's going left field. Okay, I can't play this. Alright. Going complete left field right here. Here's what we went with. Tell me if anyone knows this. You're going to be like, what the heck, Brian? If I can share one thing with you, it'll be this gentleman right here who absolutely amazes me. I went complete left field. Something that gives me the emotional feels every time. You're going to be like, what the heck is this, Brian, if you have no idea what's going on? So here's Brian's pick. Craziness right here. Check it out. Brian, the K-pop anime nerd, picked out Puddle's Pity Party, played on most postmodern jukebox. So that's Puddle's Pity Party right there. He's the clown, 6'7" or so clown, covering Sia's Chandelier. Let's see who sings it, right? Sia sings Chandelier. But check out Puddle's Pity Party, sing Sia's Chandelier. One of the most amazing voices there is. I mean, Sia does such an amazing job with it too. I don't know if anyone knows of this gentleman, but you're like, what the heck, Brian? And so Kayla just hit 100 hours, but we can't play this. We're going to get DMCA postmodern jukebox. We're just giving you shout outs right here. 100 hours, you're welcome. So check this out in the chat here. I think I dropped this link in. Go check this out if you want after this. So Chandelier. So go check that out. Sia's Chandelier. All this good stuff right here. So I guess that's got it. That's 7 years ago. I don't like getting old. I thought it just came out yesterday. Well, with that, everybody, we had some fun. We'll have to check out these songs right here. Great suggestions, great advice on songs. We will be back. We will be doing more reviews. So remember, the test is open till Thursday of next week, but we will be back. Let's end off here with a lightsaber battle. Let's do it. Let's go to our closing. What closing do I have? Let's Thanos out of here. Let's Thanos. Yeah, we got Thanos up. Let's do this. Bye for now, everyone. Bye.
Hey, Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!